Hello everyone, Professor Ajvan here. In this video I want to talk about how to identify if a given table of values can be modeled with a linear, quadratic, or exponential model. So we're going to look at three examples in this video. The three examples are on your screen now, and these are going to be what we use to develop a process for identifying each of the three models. So if whatever you're working on currently looks like these three questions, then this is the correct video for you. Let's go ahead and jump into it. So before we look at the tables, let's look at linear, quadratic, and exponential and remind ourselves what these actually are. Okay, so a linear model is in the form of y equals mx plus b, slope-intercept form. A quadratic model in standard form is ax squared plus bx plus c, and an exponential model is a times b to some x. Okay, so we're going to use these and reference these models as we look at the tables and identify some patterns that we see. So the first thing that we always want to do is look at the x values in our table and identify and make sure that they are increasing at the same rate. So we go in all three of these tables from -2 to -1, from -1 to 0, 0 to 1, and 1 to 2. So all of these x values are increasing by 1. Okay, there's no trick in any of these tables where we're jumping by 2 or by 3 hidden in here. These are all increasing by 1, so we're good to go. We're good to look at the y values. So the first thing we want to look at is the y values and the difference between them. Meaning, what do I do to go from 9 to 5? Right? What do I have to add or subtract from 9 to get 5? So we have to subtract 4. What do I have to do from 5 to get 1? What do we have to add or subtract? Well, we have to subtract 4. What do we have to do from 1 to get -3? Again, we have to subtract 4. And to go from -3 to -7, we have to subtract 4 again. Alright, so what we've identified is that we are doing the same thing each time. So this is called a first difference. Right? And this constant change in the y value is correlated to the constant change of a slope. So when we see this happen, when we see this first difference, this represents a linear model. Let's look at the second table of values that we have. What do we do? What do we add or subtract from 5 to get 3? Well, we have to subtract 2. What do we do from 3 to go to 3? Well, there's no change, so we just add 0. And what do we do from 3 to 5? We have to add 2. And 5 to 9, we have to add 4. Now looking at all of these, it is different than the first time where we had the same number to create this first difference. These are all different numbers. So we're not going to stop here. We're going to look at the difference between the differences. We're going to look at how the change in y is changing. Okay, we're going to look at the change of the change. So we're going to look at what do I do from -2 to get 0. Right, we have to add 2. What do I have to do from 0 to get 2? I have to add 2. What do I do from 2 to get 4? I have to add 2. So now that I've looked at the change of the change in y's and I see that this is the same number, this represents a second difference. A second difference is correlated to the ax squared, right, in the quadratic. So this represents a quadratic model. Our final example, we want to start the same way. We always want to start the same way in these problems and look at what do I do from 0.25 to get 1? And we have to add 0.75. What do I have to do from 1 to get 4? We have to add 3. From 4 to 16, we add 12. And from 16 to 64, we add 48. These aren't the same, so it's clearly not a first difference. And let's check and see if there is a second difference. From 0.75 to 3, we have to add 2.25. From 3 to 12, we have to add 8. And from 12 to 48, we have to add 36. So there is not a second difference either. So what's going on? We could do this again and look for a third difference, a fourth difference, but we're never going to see all of those numbers be the same. So we have to go back to the beginning. Instead of looking at what do we add or subtract from the first y to get the second y, let's look at what we multiply. What do we multiply by 0.25 to get 1? Right? We have to multiply by 4. To go from 1 to 4, we have to multiply by 4. To go from 4 to 16, we have to multiply by 4. And to go from 16 to 64, we have to multiply by 4. So we see that this is all multiplication, which is different than the first and second examples that we looked at where we had to add or subtract the same number. We are now multiplying the same number. And so this is a common ratio. And this common ratio correlates to the a value in an exponential model. So this is an exponential model. So to recap with the strategy that you should take for answering these questions, for looking at a table of values and identifying if it's a linear, a quadratic, or an exponential model, should always check the x values to make sure there's nothing tricky going on. Make sure that the x values are increasing at the same rate. You should always look for a first difference first. If there is not a first difference, check and see if there is a second difference. And if there is not a second difference, look for a common ratio. If you can't find a common ratio, then whatever table of values you might have may not be represented by one of these three models, right? Because there are many other models available. We're just looking at three of them. If you found this video helpful, consider giving it a like and consider subscribing to the channel. Thanks for watching, good luck, and we'll see you in the next one.